Hello everyone, welcome back to the Mr. Lee's Math Class videos. This is Math 1316 Trig. I'm Mr. Lee. We're going to pick up where we left off in the 5.1 notes. I'm on the next page. Convert the angles to degrees, minutes, and seconds. So we just saw on the last page that you can go from minutes and seconds back to degrees. The strategy going backwards is a little bit harder. We know this is 26.832 degrees. So we know this is 26 degrees and some number of minutes and seconds. So my strategy here is take the 0.832 of a degree and multiply it by 60 to get the number of minutes. So when I do that, I get that this is 49.92, which is not a total. You don't round it, but you look at just like this one at the whole number. So that tells me there's 49 minutes and another 0.92 minutes that will be converted to seconds. So you multiply it by 60 again. What's remaining in the decimal? And when you do 0.92 times 60, this one you do round to the nearest. This is 55.2, but we don't have subsections of seconds, so I would call this 26 degrees, 49 minutes, and 55 seconds, rounded to the nearest second. You could possibly put 55.2 if it wanted fully accurate answers, but I feel like this is totally fine. We can do one more with the negative just to make sure. Similarly, negative 42.377. This is really 42 degrees. You take the 0.377 down and multiply it by 60 to get the number of minutes that 0.377 of a degree consists of. This is 22.62, which means the 22 is the minutes, and the 0.62 then has to multiply by 60 to get the seconds. This is 37.2. So rounding it to the nearest second would be 42 degrees, 22 minutes, and 37 seconds. And you just toss the negative in the front at the end because it was there originally. And I'll leave number 10 for you to try. It should be similar. And that moves us to a few new things in this section that we'll talk about. Coterminal angles. So coterminal angles really are, if you're talking about a circle, points that are in the same place. So you're really asking yourself, how long do I have to repeat to get around the circle? And that is 360 degrees to get around the circle, which means every 360 degrees you add or subtract should get you exactly back to the same place you were before. So you sometimes get questions on the homework like find the least positive angle that is coterminal. If you have a negative angle, in that case, you just add 360s until you get to a positive. When we add 360 the first time, you get negative 344. It's not positive yet, so you keep adding 360s to notice that 16 degrees is the first and then the least positive angle that is coterminal. For the 537, if it's already positive, you're looking for another positive. If you can subtract 360 from it until you get to between 0 and 360, you're looking for the one that's between 0 and 360 if it's the least positive. Now you'll notice when you do this, you get 177 degrees. That is between 0 and 360, so this one is coterminal. I do want to note that if you already have something between 0 and 360, in order to find the least positive one that is coterminal, you'll always add 360 just one time. So I'll leave that for you because to me 27 is coterminal with 27 and that's the least positive, but usually they're looking for the next least positive one if they've already given you the least positive. So that's just a little note there. Some other things they may ask you about for coterminal is to find the two coterminal angles in both the positive and the negative direction, which means to find them in the positive direction, you'll add 360 and then add 360 again. To the negative direction, instead of adding, you'll subtract, and it wants all of them. So over here, I'll do negative 704 minus 360, gives me negative 1064. That's the first in the negative direction, and then you subtract 360 again to get what? Negative 1424. This is our second in the negative direction. To go in the positive direction, you'll add 360, which is negative 344 degrees. That's the first one in the positive, and then when you add 360 again, you get your 16 degrees. That's the second one in the positive direction. So there's slight nuance here compared to the last question. The last one was asking you for the least positive. This one is just asking for you the angles in that direction. Generally speaking, the negative direction is subtraction, positive is addition. So if they're just asking for the direction, it does not matter if your answer is negative or positive, as long as you follow the procedure of adding or subtracting 360 degrees. I want you to practice this a lot, so I want to leave both 15 and 16 for you to practice so that we can look at some of the word problems in this section. So word problems are going to require you to reason through what's going on. A tire is rotating 1,260 times per minute. Through how many degrees does a point on the edge of the tire rotate in 1/7 of a second? So we know that the tire is rotating 1,260 rotations, and I like to write it like this, per minute, so that I know where my units are and how to convert them. So if I want to figure out how many rotations it's doing in a second, I need to convert my minutes to seconds. So since minute is in the denominator here, I need it in the numerator here. 1 minute is 60 seconds. This will allow my minutes to cancel. I'll see 1260 and 60. These will get divided. So 1260 divided by 60 is 21, and it's rotations per second. So the question is, I want to know how much it's rotating in 1/7 of a second. So I have 21 rotations per second. And I really want to know what happens in 1/7 of a second. So there's no real unit here. I just want to know how many rotations are happening in 1/7 of a second. You'll notice the seconds cancel. This is 21 rotations, but it'll be divided by 7. So it is 3 rotations in 1/7 of a second to make 1,260 rotations per minute. Another example of a word problem. A pulley rotates through 67 degrees every minute. How many rotations does it make per hour to the nearest tenth of a rotation? So same strategy, 67 degrees per minute. And I want to convert that per hour and the number of rotations. So we'll work a few things now. I want to figure out how many degrees it takes per minute. So how many minutes are there per hour? To get the minutes to cancel, there are 60 minutes for 1 hour. And then this is a fraction, you multiply across, minutes will cancel. So we do 67 times 60. So that's 4,020 degrees of rotation per hour. But this is asking how many rotations it makes per hour, not how many degrees it rotates per hour. So what we really need to understand is that I need to get rid of degrees and get it to rotations. So since degrees is in the numerator, I need degrees in the denominator here, and rotations is how many I really want per hour. I know one rotation should be 360 degrees, because that's how long it takes to go through a circle. This will help my degrees cancel, and I'll have rotations per hour. So this is really 4,020 over 360 rotations per hour. And as a decimal, since once it rounded to the nearest tenth, I'll go to 1 decimal place. So what is 4,020 divided by 360? It's 11.1667. But if I'm rounding to the tenths place, this should be 11.2 rotations, rounded to the nearest tenth. And that is all for 5.1.